So homework 12, we want to take the inverses of some of these given functions. Maybe we can begin by switching the variables x and y on number 1. That would give the following equation. And now maybe what we can do is we can divide both sides by the -6. And then afterwards, maybe we can write this equation from log form into exponential form, because we can try to get the y alone. So how about we go 2 to the power of that equals that. So we have something like this. And then maybe what we can do is subtract the 7 to the other side, so that we'd have 2 to this crazy exponent minus 7 equals y to the power of 4. And to get y alone, we can take the fourth root, take the fourth power, because the fourth power knocks out the 4, and y is alone. But of course, we shouldn't call this y. We should call this function by its proper name, the inverse of h. So that is the inverse for function h there. Now, what about the next question here for number 2? We want to find the inverse of g. So right away, why don't we just switch x and y? So that would be x equals, we'd have 1/4 to the y plus 9/2 to the 1/2. So we want y alone. How about we get rid of the power of 2? Or how about we get rid of the power of 1/2 by raising to the power of 2, both sides, square, square. So these are gone. So we have x squared equals 1/4 to the power of y plus 9/2. And then we want y alone, so we can multiply both sides by 2. These are gone. So we have 2x squared equals 1/4 to the power of y plus 9. We can subtract 9 to the other side. And then we can switch the order of the equation so that we have the y on the left, everything else on the right. Now to get y alone, y is an exponent, so to get rid of it, so to get it by itself, we use a logarithm. So we're going to write this equation from expo into log form, and that would give us the following quantity here. That'll just be y. So we're done. But this shouldn't be called y. It should be called the inverse of g. So we have log of 1/4, and the argument is 2x squared minus 9. So this is the inverse of g. So why don't we just do the inverse step right away? We can switch x and y. So we have x equals log 5 minus 2 to the y. Let's write it so that the y's are always on the left. So I believe this is what we should get. Now, let me fill in a 10 right there and parentheses here. So let's go 10 to the power of x equals that. That'll give us the following quantity here. And now let's write it again so that the y's are on the left. So we have log 5 minus 2 to the y equals 10 to the x. I'll fill in the invisible base of 10. Now we can go 10 to this power equals that. So 10 to the 10 to the x equals 5 minus 2 to the y. Move the 5 to the left-hand side. So 10 to the 10 to the x minus 5 equals negative 2 to the y. Here's where you have to be careful. I'm going to divide every term individually, not by -2, but by a -1. You can't get rid of the 2 because this has an exponent attached to it, but I can squeeze in a 1 there, so it's -1. You see that? The -1 is volunteering to be removed, so I divide by a -1, -1. That'll be a negative 10 to the 10 to the x. That double negative becomes positive 5. And now it's just 2 to the power of y, because the negative got dealt with. So we have 2 to the y equals this thingy-majig there. And now the final step would be to get y alone. So we write this into log form, where that becomes the base. So it's log base 2 of that crazy stuff there. And that is what equals y. But of course, this should be called P inverse. So final result, the inverse of P is log base 2 of this stuff right here. So that was a bonus little question there. And that is the inverse.